Hi guys, my amazing biology students. Let's talk a little bit about osmosis and hypotonic versus hypertonic versus isotonic solutions, okay? So I have an example here. I have two glasses. I have this glass filled with a little bit of ice and this glass filled with a lot of ice. So when you're looking at them right now, both have 2 cups of water in them. Which one do you think is going to have or has more fluid in it? This one, Stormtrooper, or this one, a Boba Fett? Which one has more solvent? And by looking at it, I'm sure you can tell. Boba Fett. Boba Fett has more solvent. No, that's not a word. Has more solvent in it because it has less solute, right? And it only had so much space to take up. So the space that the solute is not taking up, and the solute in this case is our ice, is taken up by the solvent, the water. So now let's compare that to our Stormtrooper. Hope I can do it without breaking anything. So, our Stormtrooper had more ice, therefore less room for solvent. So when you compare these two solutions, this one is hypotonic because it has it has less solute than solvent. This one over here, our Stormtrooper, is hypertonic because it has more solute compared to the solvent. Okay, so if I put a clear tube between them, the water would flow from Boba Fett over here into the Stormtrooper because there's more fluid here. Does that make sense? Hypotonic, hypo, is called hypotonic because hypo means under. Like a hypodermic needle gives you a shot under your skin. Hypo means under. So that's a hypotonic solution. This is a hypertonic solution. When you compare them, hypotonic, hypertonic. So the fluid will always flow, because it's passive transport, the fluid will always flow down its gradient, and for us, it's from hypotonic to the hypertonic. So whenever you get a question about a cell in a solution, you always want to ask yourself, where is the fluid greatest? Okay, so let's say we put any cell, a plant cell, into a solution. And the solution that we put it in is hypertonic, meaning it has a lot of solute and not a lot of solvent when we compare it to the cell. So what's going to happen to the water inside that plant cell? If we put it into a solution that's hypertonic, meaning just like in our glass, it had a lot of solute and not a lot of solvent, where is the water from the cell gonna go? It's gonna go into the solution, and then it's gonna shrivel up. The cell's gonna shrivel up. Now, what if we put a cell, a same plant cell, and we put it in a hypotonic solution? Meaning there's not a lot of solute, but there's a lot of fluid in the solution. Then where is the water going to flow? The water will flow into the cell, bursting it, right? What happens if we put this plant cell into a solution that has the exact same amount of solute that the plant cell has? Then ain't nothing gonna happen. That's called isotonic. Iso means equal. Whenever you have a question about putting some kind of cell in a solution, You think to yourself, where is the fluid greatest? Because fluid, it's a passive transport. Fluid will always flow downhill. Where is the fluid greatest, and how is it going to flow? Okay, and if it helps you, don't think of it like a cell. Think of it like, well, if I have a cup of iced tea, and think of solute as ice cubes. Something tangible that you can really, that you can understand. Think of it like that. Okay? You guys got this.